So now I am going to show the difference between the pointwise and the uniform convergence. So pointwise convergence means you have to find a value f of x such that for some value of x, the distance between your fn of x and the f of x. After this stage, the distance between each and every curve and the limit should be less than some fixed epsilon. You will be able to find some epsilon. That is, for this point, the value of epsilon is some 0.1. For if suppose I am going to fix my x as 2, for this I need a different epsilon because the distance between these two is vary. So for each and every x you need different epsilon. So the choice of n, after what stage we have to fix our epsilon. So the choice of n depends, that is your n depends on both x as well as epsilon. Then the convergence said to be pointwise convergence. And here my fn is here, f2, f3. So I am having a collection of function fn. When we can say this function converges to f uniformly, after some stage n, you will be able to fix some epsilon, so that after this stage, the difference between my f of x and each fn should be less than some epsilon. That is, the choice of epsilon, the choice of n doesn't depends upon x. So the value of epsilon is common for each and every value of x. That is, n, the choice of n depends only on epsilon. It doesn't depend upon the value of x. Here the convergence is said to be uniformly convergence. Now look at the definitions briefly. I repeat the definition of pointwise convergence. That is, the sequence fn converges pointwise to f if for given epsilon, if x belongs to m and epsilon greater than 0, there exists a positive integer n1 such that modulus of fn of x minus f of x is less than epsilon for all n greater than or equal to n. After this stage, the distance between these two values will be some minimum for some fixed epsilon. So now next definition is, let M be a metric space, let Fn be a sequence of real valued functions defined on M. The series summation Fn is said to be converge pointwise to a function n. This we have discussed in the sequence and series class itself. That is, when we can check the convergence of the series. If the partial sum of the series converges, then the series is said to be converged. So here, since Fn is a sequence of functions, if the sequence of function Sn is nothing but the partial sum, converges to f pointwise, then we can say the series converges pointwise. That is, in order to check the convergence of the series, it is enough if we find the partial sum, the sequences of partial sums. That is, Sn is nothing but f1, f2, this is nothing but partial sum. If this sequence converges, when we can set the series, it's also